Hello? Are you there? Listen, I have an important message for you. My flight will arrive tomorrow at 2 p.m. and I need someone who can pick me up at the airport. Can you do this for me? Please call me back. Bye. Hi everyone, I'm Patrick, and in this video you will learn how you can transcribe your phone calls in real time. For this we have to do two steps. First, we use Twilio to stream the phone call to our end, and then we send it to AssemblyAI and transcribe it. And all steps happen over WebSockets, so this can be done in real time. And then, for example, we can display it on our website like here. So let's get started. So as I said, we use WebSockets to stream the data. So as first step, we want to set up the WebSocket, and we also need a web server to handle the requests. So here we use JavaScript. So we create one file, index.js, and then we require the packages we need. So we need WS for the WebSocket and Express for the web server. And of course, we need to install these. So in the terminal, we can say npm install WS and Express. And then we can set up the server and the WebSocket. So we say we create an app with Express. Then we also create a server and we create a WebSocket like this. Then we handle the WebSocket connection. So we say WSS on connection. So this is the connection event. And for now, we simply log that we now have a connection. And then we also want to set up a GET request. So a route. This will be our home route that will handle a request. And for now, we simply return hello world. So this will display hello world on the web page. And then, of course, we need to start the server. So here we log something and then we say server.listen at port 8080. And now we can save this and run this file. And then we should see listening at port 8080. So we can go to the localhost port 8080 and we see hello world. So this is working fine. We can also already try the WebSocket connection. So in your console, you can create a WebSocket. So down here we see the log from this file, and in the server, in the browser, we now create a connection with this. So we say var connection equals new WebSocket at WS and then localhost port 8080. So now if I hit enter, then we see in this console new connection initiated. So this is working fine. And now as next step, we want to set up the Twilio media stream. So for this, there exists this TweML voice stream that we need. And you find this in the documentation. I will put the link in the description. So for this, we need to do two things. So the first thing is to set up this TweML response. So this is a Twilio or the Twilio markup language. And this is a set of instructions you can use to tell Twilio what to do when you receive an incoming call or SMS or fax. And in case of a stream, it looks something like this. So we need to return a response. And here we want to say we start a stream that should stream to this WebSocket endpoint. So this is what we need to do. And then, of course, we need to handle the incoming stream messages. So for this, we also find the documentation here, WebSocket messages from Twilio. So I recommend that you go through this a little bit by yourself. But what we need to do is there are 4 important events. So connected, start, media, and stop event. So this is what we have to take care of. So let's do this in our code. So in our WebSocket connection, we now say WS. So this is our WebSocket. On message, so when a message is arriving, then we want to handle the 4 different events. So first we can parse this message. So this is the Twilio data that we get, and this is in JSON format, so we can parse this. And then we want to switch over the 4 different events. So we say switch message.event. And then we handle the 4 different types. So case connected, case start, case media, and case stop. And for now, we simply log something and then say break. And now, so the way this stream gets started is we call our Twilio phone number. Then Twilio will send a post request to an endpoint that we will handle here. And then in this post request, we want to send this TweML response back that tells Twilio to start a stream. So we will have to set up that Twilio handles this endpoint and sends a post request. So we do this in a moment, but for now, let's first implement this post request. Or this post endpoint in our case. So here we say app.post. So we need a post endpoint, and this will be asynchronous. And then here we need to return this TweML response. So we could use the Node.js package like this and then build up our response like this. Or we can simply directly return this as a string. So this should look something like this. And yeah, so first we specify the content type. And then we say result.send, and then we need a response. And in our case, we want a stream. And the URL will be a WebSocket. And at this endpoint, so this will be our host name. So this will actually then be this address. So yeah, this is what this is doing. And then we could use more instructions here. For example, we can also say this. So this will do a automatic voice for us that gives the caller a instruction. So we say start speaking to see your audio transcribed in the console. And then we wait for 30 seconds so that the caller can speak. So yeah, this is what we sent at our post endpoint. And now we need to tell Twilio to send a post request to this endpoint when a call is incoming. And of course, this is now hosted on our local host, but we need to make this public. So we need to have a public URL. And for this, we use ngrok. So this is a very cool tool that very easily allows you to have a public URL that then links to your local host. So you have to install this, and after you've installed this, you can use this in your console, and then you can use a simple command. So you say ngrok http and then the port, so 8080, and hit enter. And then you see this forwarding URL. So this is now a public URL that then points to your local host. And this is the endpoint that we need. So here we simply use a /, so we have no particular route. So we can simply use this endpoint, and then we can go to our Twilio account. So of course you need to sign up, so you can do this for free and then get a free trial with a few dollars. So I'm also still on the free trial. And the first thing you need to do is you can get a phone number. So this will be your phone number that you can use for testing. And then in your dashboard, you can click on active numbers. And then here on the right, you already see that there is a webhook with a post request that points to this endpoint. So this is when I tested this before, but now we want to use this for our new endpoint that we just created. So if we have a look back at the terminal, so this is the one we need. So we grab this and say copy, and then here we can click on this, and then we can scroll down, and down here for accept incoming voice calls, a call comes in. Then we want to send a post request to this endpoint. So now I did a copy and paste and used this new HTTP address. And this then points to our local host. So now we can click on save. And this is basically everything we need to do in the Twilio dashboard. So now we could already call the phone number that we get. So if we go back up here, this is my phone number in my case. So I could call this, and then it sends a post request to this address, which then points to the local host. And in this case, the post request will return or send this back. So this is the Twilio markup language, and then Twilio knows to start the stream, and then the stream will arrive at this WebSocket that we handle here. So this should already work now. And now as last step, we need to handle this, of course. So here is where we want to set up AssemblyAI API and then send this to AssemblyAI and transcribe it also in real time. So to do this, let's up here create a object that will be our WebSocket to AssemblyAI. And then we also create an array to keep track of the different audio chunks. And then in our post request, here we set up the WebSocket to AssemblyAI. So this only happens once when a call arrives. So now we create our connection. So we say assembly equals new WebSocket. Then here we get the endpoint, and we also, of course, need to put in our API key. So for this, I just recommend to go to our docs. So here you find the real-time streaming transcription. So here you find the endpoint and all the further instructions. So this is really cool. And of course, you need a AssemblyAI API key, so you can start for free and then sign in. And in my case, I already have an account. And then here you can grab your API key, copy and paste, and use this here. So now we have the assembly WebSocket, and now in our WebSocket connection, here is where we want to handle this now. So the first thing we do here is we check if we have a WebSocket, and otherwise we log an error and return. And then the first thing we want to do is in the connected event, first we set up that we want to log an error to assembly if we have an error. Then we create a dictionary or a map to keep track of the different texts. And now we create this on message callback. And this will execute when there is a message. So in this case, what we want to do is we want to extract the message and then either log it or maybe also send it to another website and display it. So first we parse this data. So this will be a JSON response again. And again, you can find a good documentation in here. And the way this now works, so this will send partial results as soon as it starts picking up a stream. And once the stream is complete, it will again go over this and maybe make small corrections. So, but of course, we only want to display the results once. So now basically we want to keep track of the different results. So here we store the text in a dictionary and we give it the key audio start. So this is also a key that we get here from AssemblyAI. So this will be the start time of audio sample relative to session start in milliseconds, and then the corresponding text. So we store this. Then here we simply sort this in ascending order, and then we create our final string. So we iterate over all the different keys and then append it to our message. So this way we have this in the correct order and only have it once. And then, of course, we can also simply log this for now. And later we will see how to also stream this to the website then. So yeah, so this is a event listener. So we only set this up once here in case of the connected event. And then later, whenever a message from assembly is streamed to us, then it will be handled in here. So this is the first part we have to do. Then we also want to send a end signal back in case of the stop signal. So here we say assembly.send, and then we send this terminate session key with true back. So this is the next part we have to do. And now, of course, this will be now the important part. So in case of a media event, so when we get a audio signal, a audio stream from Twilio, here we now want to send this to the AssemblyAI API. So now let's handle this media part. So let's have a quick look at the documentation again. So there is this media message that we get, and from this we get the media payload. So this is the raw audio data encoded in base 64. And yeah, there are some more relevant information here. For example, we find that the encoding is in this format, and this will be a little bit tricky because we actually need to have this in a different encoding for the AssemblyAI API. So if we have a look here we see that we need PCM encoding. So this is basically a different way of encoding the data. And so basically we need to access the payload and then convert this. And there's a very handy module or package that we can use in Node. And this is the WAV file package. So here we require this. And of course, we also need to install this. So we can say npm install and then WAV file. And then we have it. And then let's go back. So down here, now we want to access this and convert it to the correct encoding and then send this back to assembly. So here we say const Twilio data equals message.media.payload. And then, so this is the raw audio data. And then we also remove the logging here because later in our event logger, we also log something. And now here we have to convert this. So we create a new WAV file and then we say WAV file from scratch with the correct parameters. And then we have this handy method that says WAV file from MooLaw. So this decodes a 8-bit MooLaw WAV file into a 60-bit WAV file. And then we also want to get the raw audio data and basically remove the WAV file header. So we split this and then only take the second part. And then we create a new buffer and we create this now again in base 64. And then we slice this. So here we basically cut off the header that we don't need. So now we only have the audio data, so the audio information without the header. And then Twilio sends the audio durations in 20 milliseconds. But we need to have at least 100 for the AssemblyAI API. So that's why we keep track of those chunks here. So now we want to push this to the chunks and then check if we have enough chunks. So if this is big enough, if this is over 100 milliseconds, then we put this again together in one buffer. And then again, encode this, and then we send this to assembly. So here we say JSON stringify, and it needs the key audio data, and now the encoded audio. And then we empty the chunks again. So yeah, this might be a little bit tricky to have it in the correct format, but yeah, here is the steps that you need. So you can also find the code on GitHub. I will upload this and put the link in the description. And yeah, this is basically everything that we need. So now this should already be working. So one also important thing I want to mention is that here in the endpoint, we also can specify the sample rate. So in our case, this is only 8,000. And yeah, so now let's do one more step. So instead of returning hello world, we want to now display this on the website. So here, instead of returning hello world, we want to send a file. So we say result send file, and then here this will be our index HTML file. And then up here we also need path. So we say const path equals require and then the path. And then, of course, we also need a index HTML file. So I already prepared this here. So this is a simple HTML syntax where we give it a h1 tag, a h3 tag, and then in here we paste in a script. And here we add a event listener where we also create a WebSocket at this port 8080. And then we say also this on message event handler, and then we extract the data, and then we give it this event ID interim transcription, and then we set the inner HTML to data text. So basically here we set the new text to the website. And now in our index.js, also when a new text arrives, so in here we log the data, and now here we also want to send this now to this WebSocket event. So let's do this. So here we say WSS.clients for each client. So we can basically also stream this to more clients. So, but in this case, we only have one more, which is the WebSocket client that we have here. And here we say if client ready state equals WebSocket open, then we send a message. So we stringify this and we set the event to the same event that we use here. And then we want to send a text key as message. So the text is basically here what we extract at this side. And yeah, this is all that we need. So now we can save this, and then again, so let's stop this and run this again. And now we can go to the localhost 8000, localhost 8080 and reload this. And now we should see this index.html. And now let's start or try calling our phone number that we see here and test this. Test, is it working? Yeah, the text is coming, super cool. So I hope you enjoyed this tutorial, and I hope you subscribe to our channel, and then I hope to see you next time. Bye.